tutorial where I'll be answering this past paper. Alright. Our first question says, which of the following is the same as 6.0 times 10 to the power 6 nanometer? Alright, what you should know here is that a nanometer is a prefix, and it is a short way of representing a number that is raised to 10 to the power of, it's a short way of representing a number that is raised to 10 to the power of negative 9. So in this case, we just have to convert 6.0 times 10 to the power 6 nanometers into meters only. So to do this, we just have to multiply it by 10 to the power of negative 9. And when you do this calculation, you have your answer to be 10 to the power of negative 3 meters. So, and the option that seems to correspond with my findings is actually option B. Alright. Question 2 says, Elena wants to measure the volume of a piece of wire accurately. The wire is about 300 meter long and 0.02 meter in diameter. Which measuring instrument should Elena use? I don't know if you're familiar with this, but there's actually a very nice way of understanding with precision the name of the measuring instrument to use. Right. So this should be noted carefully. For for a measurement that is ranging from 0 to 2.5 centimeter, the measuring instrument that is used is a micrometer screw gauge. And for a measurement that is ranging from 0 to 15 centimeter, the measuring instrument that is most suitable is a vernier caliper. In the same vein, for a measurement that is ranging from 0 to 1 meter, the instrument that is most suitable is a meter. And lastly, for a measurement that is ranging from 0 to 5 meter, the measuring instrument that is most applicable is a measuring tape. Alright. Okay, so we're just gonna use that rule and quickly solve this question. Right. So we are told that the wire is about 300 millimeter long, which when taken in meters is about 0.3. Remember, I said for a measurement that ranges from 0 to 1 meter, the most applicable instrument to be used is it's a meter rule. So in this case, we are going to shortlist option A or B. Then for the diameter, right, if we convert 0.02 to centimeter, we'll have a value of 0.2 centimeter. Like I said, for a measurement that ranges from 0 to about 2.5 centimeter, the most applicable instrument to be used is a micrometer screw gauge. So in this case, we'll confidently choose option A to be the correct answer. Question 3 says, a car started from rest and accelerated at 300 meter per second squared. What distance is covered by the car after 2 seconds? Right. So in this, we're just gonna make mention of the equation of motion, which says S is equal to ut plus 1 over 2 at squared. Right. In this case, since they have mentioned that the car started from rest, meaning that u, which represents the initial velocity, is 0. So we'll say S is equal to 1 over 2 a. A means acceleration. From the data given, the acceleration is 3, and t means the time. from the data given, the time is 2, so we're just going to square that. So we'll have 2 over 2, which is 6 meters. So this corresponds to option C. Question 4. The following velocity time graph shows the movement of a cyclist. What distance was covered by the cyclist while his velocity was constant? Right. So for a distance, for a velocity time graph, the area under the graph helps us to calculate the distance. So if we just basically find the area under the graph, then we have found the distance. However, this question has a bit of a twist in that it requires a specific portion of an area. So this is a portion where the distance, the velocity of the cyclist was constant. So now we have to interpret the velocity time graph to know exactly where that region is. Okay, so from this region, from time 0 to 1 to 2 meters per second, we can clearly see that the velocity in this case was increasing. So it is not this point that I want. And from this point here, from 2 to 3 seconds, we can see that the velocity stays constant. So surely the examiner wants us to calculate the area under the graph for this portion. Right. The shape of this portion is actually a rectangle, and area for a rectangle is L times B. Right. The L we should take is 15. However, the B should be 3 minus 2, so that we just have the value of that portion there, which is 1. So having this, we'll have 15 meters. Therefore, option C seems to gather that value. Alright, question 5 says 2 points B1 and B2 are set up a vertical distance z apart as shown in the following diagram. Releasing the steel ball from rest from a point a distance x above B1, it is found that the ball takes time t1 to reach B1, right, and time t2 to reach B2. Which of the following is true about the acceleration of the ball as it falls downwards? It is right. Okay. Neglecting air resistance, physics tells us that the acceleration of any body is the same. So any body, regardless of size, if we neglect air resistance, it falls with the same acceleration, which is about 10 meters per second squared. So in this case, right, so we safely choose option C, which says the same at both B1 and B2. Right. Question 6. A woman was standing on a platform at the railway station as shown in the following diagram. The woman started timing when the head of the train reached where she was standing and stopped the clock when the tail of the last stroke passed. If the train was traveling at 30 meters per second and took 3 seconds to bypass the woman, what was the length of the train? Very simple question. Length is the same as distance, so distance is basically speed times time, and the speed is 30, time is 3. So from this we have a value of 90 meter, which is option A. Question 7 is about pressure. The following diagram shows a uniformly shaped container with 4 vertical tubes of different shapes and sizes. A learner pours water into the container up to the level shown in tube 1 and then stops. Which diagram shows the level of water in the tubes 1, 2, 3, and 4 thereafter? So this question is a typical question that tests our understanding of the factors that affect pressure. Right. What we should know is that the pressure is independent of the shape, right? So basically, what we should expect here when water is poured into the various segments of this whole entire beaker is that they should all be at the same level, right? So they should all be at the same level. What I mean is this. So option C has that point. This means that the pressure acting is the same, right? So it tells us that the pressure is the same, and that gives an arization to a well-known statement which says that pressure is independent of the shape of a body, right? So option C is the correct answer for that. Question 8. A box of mass 72 kg is placed on the floor with base measurements as shown in the following diagram. What is the size of the pressure exerted by the box on the floor? Right. Pressure is given by force over area. So in this case, the force will be equal to mg, which is basically 72 by 10, right? So for force here, we'll substitute 720, right? And the area is given by L times P, which is 1.2 times 0.8. So if we do our calculations there, we find that the value is actually 750 pascals, which is corresponding to option A. Okay. Question 9 says heat may travel in solids through. This is a very simple question. Heat travels in solids through conduction. Okay, question 10. An electric kettle is used to convert 0.5 kg of ice at minus 10 degrees Celsius to steam at 100 degrees Celsius and consume 27,000 joules of energy. Given that the heater in the kettle has a power rating of 300 watts, calculate the time it takes to convert the ice into steam. As funny as that may seem, uh, this information was basically useless. Alright, so what we should know here is that power is equal to energy over time. So if we have energy and power, then we can simply calculate the time it takes by simply dividing that and that. So here I have 900 seconds. 90. Sorry, I have 90 seconds. Okay. And if we convert 90 seconds to minutes, we should have about 1.5 minutes, which is option B. Simple. Right. Question 11. A substance originally in its solid state is heated. Latent heat of vaporization results from the energy given to the substance at one stage. At the latent heat of vaporization state, what energy change? What change does the energy cause? Statement A says breaks the bond holding the molecules together and molecules escape from the liquid. This is definitely correct because latent heat of vaporization refers to the process a substance undergoes phase change from liquid to gas at constant temperature. And the temperature is constant because energy is used to break the bonds that are holding the molecules together. And once the bonds have been broken, molecules escape from the liquid. So they escape from the liquid to become gaseous. So option A is correct. Question 12. Elena performs an experiment by placing a thermometer in a test tube containing a hot liquid. After every half a minute, the temperature of the liquid is recorded as shown in the following diagram. What is the melting point of this substance? Okay, melting point refers to the constant temperature at which a body in solid state changes to liquid. So the key idea there is that the temperature is constant. Therefore, in here we just have to find where the temperature is constant, and it's actually on the part of 62 there. So here you find 62 and there you find 62. So this implies a melting point. So confidently choose option C. Question 13. A wave whose frequency is 2 times 10 to the power 6 Hz travels at 30 meters per second. What is its wavelength? Right. In answering this question, let us make mention of the wave equation, which states that wavelength, denoted by the symbol of lambda, is equal to speed over frequency. Okay. The speed is 30. The speed is actually 30, and the frequency is 2 times 10 to the power of 6. Alright, doing some basic math here, you find that the answer is supposed to be B. Question 14. A wave has a wavelength of 1.5 meter and its frequency is 40 Hz. Which of the following pairs correctly represents its speed and period? Okay, so we use the same equation to answer this question as well. Right. For speed, we are given that V is equal to lambda times the frequency. So in this case, we're given lambda, which is wavelength, as 1.5 times the frequency as 40. Doing your basic math here, you have a speed of 60 meters per second. Right, so we can shortlist the answer to be either A or B. Then the period is given by period is equal to the inverse of the frequency. So the frequency is 40, so an inverse of 40 will give you 0.025, right? And that corresponds to option B. Question 15. The following diagram shows waves passing through a narrow gap. The effect is known as... Right. Okay. So for this question, the effect here is known as diffraction. Whenever a wave passes through, whenever a wave spreads as it passes through a gap, the process that occurs is diffraction. And this is what we can see here. We have a slit there, and as the wave strikes the slit, it is found that the wave it spreads. So this spreading of a wave as it passes through a gap is called diffraction, and it's actually one of the 4 properties that waves have. The other property that waves have is interference. Interference is basically a phenomenon that occurs when 2 waves meet, and another property that waves have is reflection. Reflection basically refers to the bouncing back of waves when they strike a barrier. And another property that waves have is refraction. Refraction basically refers to the change in direction of a wave as it changes media. So for the above diagram here, the characteristic, or rather the property of a wave that is demonstrated is diffraction. And another way ECZ might bring the process of a demonstration of diffraction is like this. When we have a barrier, suppose we have a barrier like this, and we have incident wave front. So when this incident wavefronts go around an obstacle, go around an obstacle like this, so they go there. The process that occurs here is also said to be diffraction. It's another definition of diffraction. Okay. In case they brought a figure that may appear something like that, that's how you go about it. Okay. Question 16. A sound wave is generated by a guitar. When struck the second time, the sound is louder. This is because the second sound has a right. What you need to know here is that loudness of sound is basically related to amplitude. So the loudness of sound depends on the amplitude, and you should also know that the pitch of a sound depends on the frequency. So in this case, the reason why the sound is louder is because it has a larger amplitude. Alright, so option B is correct. Question 17. The sound from the siren of a ship is reflected by a cliff. An echo is heard by a sailor the ship of a on on the ship of on the deck of a ship, sorry. 4.0 seconds after the siren is sounded. Take the speed of sound in air to be 320 meters per second. How far from the cliff is this ship? Right. Okay. So how far means distance. So distance is equal to speed times time. So in the case of an echo, which is the bouncing back of a sound wave as it strikes a barrier, so the reflection of a sound wave. So you have to divide it by 2 because the sound wave travels like 2 times the distance to go back and forth. Right. So we have our speed to be 320 and the time to be 4 over 2. So like this I'll have a value of about 640 meter, which is option D. Question 18. A pulse was directed towards the wall and the time it took for the reflected pulse to return noted. The pulse consists of wavelength, speed, and frequency. Which pair can be used to find the distance to the wall? Right, I feel like this question is just it's just a repeated version of what we we were discussing, right? So a pulse in this case just basically refers to a signal, right? For the signal to go back and forth, it just means that there is an echo here, and for us to find the distance, we have to have 2 factors, which is the speed as well as the time. So the option that incorporates this idea is option C, which says speed and the time taken for the pulse to return. So I'll confidently choose option C. Question 19. A ray of light strikes a smooth plane mirror and is reflected as shown. Which pair of angles must be equal in value? Right. So the pairs of angles that are equal in value is x and y, as well as w and z. Right. X and y. So option C there. Question 20. The image of an object formed on a screen by a lens is blurred. How can the image formed on the screen be made clear by? Right. So it's a very challenging question to explain, but I'll try. So the reason why it is blurred is because um, the image is formed in front of the screen. So for us to make it clear, it implies that we should find alternative means in which the image can be formed on the screen like that. So the light rays need to meet on the screen here. So for us to do this, we have to decrease. We have to take the object much further, if we take the object much further, this means that the distance of the image from the lens um, will also like increase. So um, which option says moving the object away from the lens in the screen. Yes, if you move the object away from the lens in the screen, the light rays will be formed, at least they will be formed near the screen. So if they are formed much closer to the screen, it means that the image is much clearer. So I think I should go with option A here. Right, question 21. Which of the following is a correct set of properties of the image formed in a magnifying glass? Right, for the image characteristics of a magnifying glass, there are three, and the image is virtual, it is upright, or rather it is erect, and the image is diminished. And the option that seems to have this is option 3, which is virtual, diminished, and upright. So it is also of importance that you know that a convex lens can also be used as a magnifying glass in a case where in a case where in a case where the object is placed between the focal point and the center of the lens. So in this case, the light rays will meet like that. So that's a scenario in which you can use a convex lens as a magnifying glass. Just wanted to add that there. Okay. Right. Question 22. Rays of light enter and leave a box as shown. What could be inside the box at Q to make the rays behave as shown? It's a very tricky question, and okay. I don't know if you know this, but when answering multiple choice questions, there are actually two ways in which you can do this. You can use pinpoint accuracy and just go straight to the answer, or in the case where you're confused, you can try to eliminate the options. So let me do that. Let me do that because explaining the answer directly is going to be very challenging. Okay, so we'll start with statement A, which says um, converging lens. Right. If it were a converging lens, we know the characteristic of a converging lens is that it makes light rays to come at a point. So it makes the light rays to come at a point. And this point is actually called the principal focus. So in this case, ray K is like appearing on top of that, and ray J is like appearing the bottom of ray K. So in this case, we can clearly see that the image, we can clearly see that object or rather box Q is not a converging lens because the light rays are not directed onto a point. Okay. In the same vein, option B says diverging lens. Diverging lens will scatter the light rays. So they will scatter the light rays like this. And in this case, the light rays are not scattered. Therefore, option B is also incorrect here. Option C says plane mirror. Okay. If it were a plane mirror, remember, mirror would just basically reflect the rays. It would just basically reflect. However, in this case, the light rays enter the medium, so it's not a plane mirror. It must be a rectangular prism. Okay. Question 23. The following diagram shows an electromagnet. Which of the following pairs is correct for the identity of poles R and T, as well as the material for the core and coil when the switch is closed? Right, even before we go through the choices, let us get to solve this question. Right. Um, basically, here you have to understand what an electromagnet is. An electromagnet refers to a temporal magnet made by passing direct current through a coil containing soft iron. Right. So when you pass direct current through a coil containing soft iron, um, uh, then you form an electromagnet. Right. So in this case, in identifying T is supposed to be the core. So the core, um, and this core is in most cases soft iron. Right. Then R. Sorry on that. Okay, sorry on that. I thought T was referring to this point. Actually, it's a polarity. Okay. So even before we get to identify the core and coil, now let us get to know how to determine the polarities, of this electromagnet that is formed. Right. So to determine the polarity of an electromagnet, a method is employed. It is called the Fleming's right hand grip rule. Okay. The Fleming's right hand grip rule entails us that if a person holds a conductor in such a way that the fingers curl in the direction of the flow of convectional current, then it is expected that the thumb of that person um, points towards the direction of the North Pole. Okay, so here it's what it means. Remember, convectional current entails us that current flows from positive terminal to the negative. So we'll have the flow of current in that order there. Okay, so here we expected to grasp this conductor like that. So if we hold the conductor like that, so if the rest of the fingers hold the conductor like that, it is found that the thumb will automatically point in the direction of the North Pole. So if you're doing this, you find that T is actually a North Pole there. And if this north, then R should be south. Okay. So I said T is north and R is south. So the answer can either be A or B. For the core, soft iron is used, and for the coil, copper is used. So option B is the one that seems to cater all of what I have said. So we go with B there. Alright. Question 24. The following diagram shows the double stroking method being used to make a magnet. Which of the following is the resulting magnet from the diagram? Okay. All right. So here, for us to determine the polarities again, for double stroking method, you have to know that um, if you're stroking with one pole like that, then the end where the stroking finishes, so in this case at this point, that's where the stroking finishes, will acquire an opposite pole as an opposite pole to the stroking pole. So if you're using south here, then at this end where the stroking finishes, it is expected that you have a north pole. In a similar way, if you're stroking with a north pole here, then the end where the stroking finishes will acquire an opposite pole to the stroking pole. So here we should expect a south pole here. So north, south. Right. So that is option A. Alright. Question 25. Polyethylene board is wrapped with fur and charging occurs. This is because, alright, now, alright, this question actually demonstrates the process of charging by friction, right? Mm, okay, and the example used um is okay. Let me just explain what I'm saying. So they're saying that if a polythene rod is rubbed with fur, then charging occurs. Charging basically refers to the gain or loss of electrons. So it is the electrons that are concerned. So when polyethylene rod is wrapped with a piece of fur means clothing, right? Then the fur loses electrons to the polyethylene rod. You just have to know this. Right, the fur loses electrons to the polyethylene rod, therefore thereby making it negatively charged and itself becoming positively charged. Another typical example of charging by friction that you might be given is when you rub a perspex rod with a piece of cloth. So in the case of a perspex rod, something else, it's actually the opposite that occurs. The perspex rod is found to lose electrons to the cloth, thereby itself becoming positively charged. So in this case, the perspex rod becomes positively charged, whilst the cloth becomes negatively charged. So these are the two common examples that you have on charging by friction. Okay, so let me get to the statement that has this. Okay, statement A says electrons move from far to polyethylene. Yes, this is exactly what I have been saying. Okay, question 26. A negatively charged rod was brought near an insulated and isolated and charged conducting spheres. What will be the charges on x and y, x and z of the sphere? Okay, so if you bring negative, okay, so we have a sphere like that mounted on an insulating stand. Then if you bring a negatively charged rod close, okay, have they said not touching? What will be the charges on sides y and z? Okay, it was brought near, so it's not touching, it's just brought near. So when this occurs, we'll follow the basic law of magnetism, which says that like poles, so in this case like charges attract. Oh, it's actually the basic law of electrostatics, which says like charges attract. So if we bring a positive, a negatively charged rod like this, then electrons that are present on this surface will be repelled by the nearby electrons there. So the electrons will now move to this side, and if they move on this side, it will make this side to be partially positive, right? So we expect y to be positive and z to be negative. So y will be positively charged while z will be negatively charged. So option B. Question 27. Which of the following is equal to the work done when moving a charge across a component in a circuit? So this is very simple. This is actually the definition of potential difference. For electromotive force, don't confuse between the two. For electromotive force, it is the work done in driving one column of charge throughout the circuit. But for potential difference, it's just across a component. Okay, so all right, calculation away. 28. A power supply of 18 volts 18 volt is connected to 3 resistors as shown. What is the potential difference across the 2 ohm resistor? Okay. Alright, so we'll solve this question using 2 steps. Step 1, we'll first find the current that is flowing in a case where this part actually here is connected in series. So we find the current that flows here, and after that we'll just basically use V is equal to I times R to find the voltage at the 2 ohm resistor there. Okay, so current is equal to V over RT. So RT just means the total resistance. The total resistance for the resistors that are connected in parallel, since there are 2, we just have to half them. So it's actually 4 plus 2, which is 6 ohms. Alright, then I will now be given by V, which is 18 over 6, equal to 3 amps. So meaning that if the 8 ohm resistor as well as if the 2 8 ohm resistors were connected in series, then the current that will flow throughout the circuit is supposed to be 3 amps. Okay, so now since we have the current that is flowing in the circuit, we just basically use the formula V is equals to I times R, and I in this case is 3, while the R is 2, thereby having a value of 6 volts.